Okay, so we have geometric distribution, okay, and you'll notice there's 4 rules. The cool thing is that my first 3 rules are the same as binomial, so let's check that out. The outcome for each trial is classified as a success or a failure. Trials must be independent. The third one is about probability. Each trial has the same probability, P for success. These match binomial. Okay, and the last one's different, okay? Number 4 before, okay, was that each activity had a set number of trials, okay, a set number n. And in this case, it's a little different. The number of trials, n, is determined by the first success. Okay, so let me show you what that means. Let's assume Carter makes 83% of his field goals of 50 yards or larger, okay? Let's let y be equal to the number of field goal attempts until he finally misses, okay? And that looks weird to say this, but we'll say a success is a miss, okay? Meaning, if he has successful field goal attempts on his first and second attempt, but is unsuccessful on his third attempt, y is equal to 3, okay? Assume that attempts are independent. So first, let's make sure that this is geometric. First rule is there a success-failure relationship? And there is. And again, it sounds backwards, but a success is a miss, as you have capitalized with all letters there. Okay. Are they independent events when you do these kicks? Yes, they are independent, as it states. Does your P stay the same? We'll assume it does, okay? With all the kicks that Carter's done, there's such a long and time frame where he's done all this work, and I'm sure there's a lot of kicks within. So we'll assume with this long series of events that his P will remain around 0.83 or 83%, okay? And the last thing is, does N determine, is the first success determine the set number N? And in this case, yeah, they're saying when the probability of y is equal to 5, they want to know, hey, you know what, the first 3, nothing big is going on, but the last one is significant, okay? And so what are we going to do for this? Well, what is the probability that this is a success, meaning that he misses? Well, the probability of a make, we said was 0.83. So the probability of a miss is 1 minus 0.83, which is 0.17. Okay, so that will go here. And the other ones aren't misses, they are actually makes. And so that'll be 0.83, 0.83, 0.83. Okay. What would I do with all these? Well, this is 0.83 to the third power times 0.17. Some may ask, do I put like a combination component out front like we did in the other ones? And the answer is no, okay? And the reason why is that we have to be very strict about our order here. I need this success, this 0.17, to be in the back where it's the 4th trial, okay? If it was 17 were somewhere else, then you would have a different variable for, or sorry, a different representation for y. Y would be a 3 or a 2, okay? But I need the 4th one to have this success, which is 0.17. Okay. If you're to do this math, you would get 0.0972. Okay. Awesome. Do that in a calculator. Now, some people are big on formulas. And if you want a formula, there's one right under me. I can see it. Look down right below me. It's in bold. And the only difference between what I have here and my work and what I have here is just, these are just variables that haven't had values inputted into them, okay? So if I want y is equal to 4, because I have that off to the left here as my question, then I'll put in my P for success, which is 0.17, and it'll also go here, 0.17, and my K is 4 minus 1, which is 3. All right, so if you look at all of this, like the 1 minus 0.17 to a power of 3 times 0.17, that's what you have here, okay? Now, some of you are asking, you know what, I don't mind doing it that way, but there must be a graphing calculator way. And of course there is, but you have to hit seconds and then var, so that's your distribution. You'll get that same screen that we had before, but I'm not, in this case, looking for A and B. Let me scratch those out. These are not binomial. Geometric are actually at the bottom, where F is. Okay, and so what I'm doing here is I'm doing with my TI-84 a geometric PDF, and I got, let's see, P and X. Okay, you're like, wow, you only need 2? Yeah, check it out. Okay, your P for success here, again, is 0.17. And the number of values you're seeking are 4. Okay, and so I'll write those in here, 0.17 and 4. And if you hit enter, you will get 0.0972, just like I had before. Okay, so this answer is consistent. All right, again, you can use your graphing calculator every time. Just make sure you show this type of work here. Make sure you write that syntax. Okay, and the answer. All right, now with binomial, it was possible to have a y is equal to a 0 or an x is equal to 0. Those are both okay for binomial because, for example, in JLO's 8 shots, it's possible to make none. Okay, that's a potential x value, okay, within your work. However, if you keep doing a trial until you satisfy an event, okay, it's different here. Can you satisfy an event on the 0th try? And the answer is no, it doesn't make sense. Okay, so what I would say here is that it's not possible. Alrighty. All right, cool. Now the next one is no different from the previous. It's just multiple questions into one large question. Okay, so if I see y is less than or equal to 3, that's really y is equal to 3, y is equal to 2. Sorry, I wrote p's. And y is equal to 1. Okay, now for myself, okay, first of all, I know there's no y is equal to 0. And the reason why is because we just showed that y is not equal to 0. Can't happen. I could do a geometric PDF for each one of those, okay? Or I could write it like I did in number 1, okay? And in the end, I could add up all those answers, okay? But it may be easier to do a different command, okay? And like binomial, if I want something more than just a standard value, okay, like for example 4 or 0, and I want an inequality, that is where you use your geometric CDF. Okay, so I'm going to write that TI-84 geometric. Okay, CDF. Okay. Your probability is still the same, 0.17. Okay, and I'm going to go as high as the value that I see here. So when I see 3, 2, and 1, I'm going to put a 3 here. All right, and if you do that command, it does all your work for you. Okay, so geometric CDF with 0.17, and in this case we have a 3, and you end up with 0.428. Okay, and you'll notice that if I kept going one more step, you'll get that 0.428. Okay, and that's what the screen shows. That's what this shows on your home screen. Okay. All right, last one of this type. What is the probability of getting the last field goal kick to be a miss on your greater than 7 try? Okay, and so what this means is that works for 8 or 9 or 10 or 11 or 12 or so on. It could really go on forever, and I didn't want that to happen. Okay, hang tight. I'm going to keep this. I'm going to go back. Good. I didn't want to start over. When I do the ... it clears everything out, which isn't good. All right, and so this is what I'm looking for, but unfortunately I can't put these calculations and have them go on forever, okay? So here's what I'm gonna do, okay? If 8, 9, 10, 11, 12, and so on represent this piece, I need to think of the reverse. What represents the numbers basically 1, 2, 3, 4, 5, and 6, and 7, okay? Because these 7, okay, with respect to making field goals is the complement, probability-wise, of the probability of 8 or more, okay? 8 or more is the same thing as greater than 7 when you're talking about those whole numbers, okay? So here's the idea. Since this is impossible to figure out, what I'm going to do is I'm going to do 1 minus the probability of getting 7 or less, okay? And that's what is the reverse of what you see here. Okay, so I'm going to do geometric, and I'm going to get my screens back. Okay, and this is a CDF. Okay, and I'm going to put the 1.17 in first. And because this is C, it's cumulative, I want everything from everything from 7 or less. Okay. And if you do that correctly in your graphing calculator, you can see that that's written right here. Okay, you would end up with this number. Okay, now notice that the 1 minus is not out in front of your calculator here. So you can write 1 minus, and this is point, let me use my glasses just for a moment, 0.7286. 3, just for good measure. And if you do that subtraction, you get 0.2713. 7. Okay, and so again, any value that has a greater than sign with it, you're gonna have to do 1 minus the item that's directly below it. So in this case, 8 is the first number that satisfies it. The whole number below it, okay, is the representation that you'll use for this part over here. Okay, that one that's below it. All right, that is the end of the geometric piece, but there's still one more part, okay, that's a little bit different. It's again moments where we ask for the word expect, okay? And it's the same story that you saw above. So that first paragraph says, how many attempts would you expect Carter to have until he finally fails on a field goal attempt over 50 yards? And then it's just rewritten. It says, meaning how many attempts would he need on average to finally fail at a 50-yard field goal, okay? Now you're gonna like this formula more than any one that we've had this year, okay? Because when you see it, you'll say, mu of y is equal to 1 over p. So does that just mean it's 1 over? Now, what is the percent for a success here? Remember, success was missing a field goal finally, which is 0.17. Okay, and that's really just probability for a success. Okay, and 1 divided by 0.17, I believe, is 5.88. Okay, which it is. All right, last thing. In addition to a mean, there is always a standard deviation, okay? And I'm going to share that in the past, when I first learned to teach this class, they didn't provide a standard deviation for a geometric because it could typically go out forever. And that was always the reason I thought that you could really kick field goals and never ever miss if you're Carter, and maybe he kicks 7,000 in a row without missing. You know, kind of goes infinitely out in that direction. We're kind of at the mercy of how good our kicker is, okay? Nevertheless, a standard deviation apparently does exist, and I didn't know it until now. So when I say now, that means within the last year. And it goes like this. You won't have any questions in your book on it, but I do want you to know how to find it. Okay, even though it's not a textbook question. And you may have to know it for your test. Okay, so just keep that in mind. Your P is very simple. It's just 0.17. You'll plug those in. and that gives you the square root of 0.83 over 0.17, and you should get 5.35. Okay, what does that mean? Okay. When you think about all the activities where he kept kicking field goals until he misses, okay, on average, okay, the number of trials that'll take for him to finally miss a field goal will vary by 5.35 to the mean. Okay, but that is what I got for that. I'm going to check it to make sure, and I think I'm good. Okay, all right, here is your assignments. Okay, that's from the Practice of Statistics, units 7, okay, 7.3, 6.3, sorry, 6.3. Sorry I was a little groggy during this this little presentation. It is past 1 a.m. for me, so I gave it my best. My eyes are only about half open, but I probably gave 50 trials of this trying to make sure that it was right, and I think I finally got it. So anyways, if you have any questions, let me know. Have a good day.